This conference will now be recorded.
So very good evening, students. Today we'll be discussing few numerical problems on this chapter waves. Actually, there are many good problems depending on various concepts we have learned, and this chapter is very important for competitive exams. So today we are going to discuss numerical problems. Another class we will be discussing more important numerical problems, and then last class I'll take on Doppler effect of sound. Okay, so that will be the end of the chapter. So let us start our business today. So here I have collected few questions and corresponding options are given. You have to choose the correct option. In fact, you have to first solve it and then you have to choose the correct option as the answer. So let us first start with this problem. The problem is here the equation of a progressive wave is given. Progressive means the wave can propagate. The nodes antinodes propagates one point to another, and these propagation waves actually they can propagate in both directions. Okay, so we can see in in the progressive waves, one main property is that the wave will travel in a particular direction and its amplitude will be constant. All right, see the question is y and x are in centimeter. So y is equal to this is 4 sine pi whole into t by 5 minus x by 9 plus pi by 6. You know what you have been asked? You have been asked to find out which of the following parameters are not like which of the following parameters is correct one. So what are the parameters we can find out from this particular equation? We can find out velocity, we can find out lambda, we can find out amplitude, lambda means wavelength, we can find out frequency as well. So these four parameters we can find out, but you can see here directly things are not given. So whenever we are going to solve this kind of problem, then better to write the standard form of the progressive wave and compare it. You might not be understanding what I'm saying, but let me just write the standard form of this type of progressive wave. See what we have t over here. We have, see, we can write y is equal to a sine omega t minus kx, but this is not the one here. K is not there, right? Then there must be something else. So see this k we can actually, and see this is actually phi phase. So this form itself can be transformed. How can we transform this? See k means propagation constant. This can be written as 2 pi by lambda. Okay, 2 pi by lambda. Let us just write that 2 pi by lambda, and then we'll do some modification. So I'm just not writing directly. I'm actually helping you to learn how to find out the similar form what is mentioned here. So let us first write omega t minus 2 pi by lambda into x. But still it is not matching with the form given, right? Because with x there is no pi. With x there is no pi. So let us just take 2 pi common. Okay, 2 pi common. Only you have to keep x in the numerator of this term. So this itself can be written as a sine of, let us take 2 pi common. Okay, 2 pi common. Or here only pi is there. Let us just take pi common. Better would be if we take 2 pi common. Let us take 2 pi common, then we'll see what happens. So then we get omega t. See, there is no pi here. Okay, or we can write. Okay, let me write here. This one is the, and here x by lambda. At least we have got this term all right. Okay, see, further I'll go. This is not so many steps. I'm just teaching you. If you forget the standard form of this, then how you can do. So that is what I'm actually teaching you. So see, now we have almost arrived to the standard form. Let us write 2 pi here. See, this 2 pi by omega or omega by 2 pi. See, we know a relation. Time period is equal to 2 pi by omega. Okay, so we can write this as 2 pi by omega down. So we can write t by capital T. This is time, arbitrary time. This is the time period of the oscillation. And see, we have got this x by lambda already. We have got, and we have got phi over here. All right, now you can see the equation I have written now here is similar to the equation given. I'll just compare. Suppose this is equation number 1 and my equation is number 2. Okay, look, just compare. This is, okay, they have written this as small a, amplitude small a. I am just writing as small a then. So if we compare, this is c pi, here it is pi, but we have 2 pi over here, nothing much different. And this x by 9, we have x by lambda. Okay, so what we can do, let us just uh, okay, let this be there, let this 2 be here itself, because this is the standard form, 2 pi and this. Okay, let us compare. So a will be, amplitude of the oscillation will be 4 centimeter. Okay, then what is the velocity, what is the lambda? So lambda is here this much, right? But you have to anyway multiply 2 down so that this 2 will get cancelled, right? So see, from here, if we comparing 1 and 2, equation of 1 and 2, what are the things we are getting? First of all, a means amplitude, that is 4, that is a fixed quantity. Then lambda. See here, x by 9, and here you have 2, sorry, pi, only pi, but you have 2 pi over here, and you have x by lambda. So if you multiply 2 here, then only this will be only pi. So comparing these two, we can write that the it is lambda by 2 is equal to 9 centimeter. Okay, it is lambda by 2. All right, so it is lambda by 2. is equal to this. All right, so then your lambda will be 18 centimeter. You just compare this equation 1 and equation 2. That's how we are getting actually. If you have some doubts, you just look closely. See here 2 pi is here, but in the main equation given here is pi. So you have to multiply 2, okay, so that you get only pi. Or you can do another thing. The lambda we have here, that is actually lambda by 2. That if you think, then it is this much is equal to 9 centimeter. All right. So this is how you can find out lambda. So we have seen that this answer is wrong. Lambda is 18 centimeter, fine. And what else is wrong? Let us see. So we have found out lambda to be 18 centimeter. Okay, we can just remove this part so that we can do some calculations if required. Let this also be erased. Okay. See, now we have to see velocity. Velocity. How do you get velocity? Before we get velocity, we have to find out frequency. Let us go for frequency first. So frequency means what? 1 by t means frequency. Okay. 1 by t means frequency. So here, what is there? See, pi and t. So this should be t by 2 actually, what you have here. So this is t by 2. Okay. Or you should write 2t. 2t is equal to 5. Okay. So actually 2t, we get 2t is equal to 5. So t will be 5 by 2. Pi into 2 by t. So just a minute. Better if we write this 2 here and it is here. So this will serve your purpose. Okay. So t by 2 is equal to 5. So t is equal to actually 10. So t is equal to 10 means frequency means 1 by 10. This will be hertz. Okay, per second. So 0.1 hertz. Okay. So this should be 0.1 hertz. Frequency should be 0.1 hertz. All right. So we get frequency is equal to 0.1, but what is given? 50 hertz. This is also not true. Then what is the velocity? Velocity will be given for a wave. We know there is a relationship between frequency into lambda is equal to the velocity. So we know the frequency is 0.1 and lambda is 18 centimeter. That is equal to v. That means what? V is equal to 1.8 centimeter per second. So this is the velocity. Okay. But what is there? The velocity is given as 5 centimeter per second, which is not true. So only correct option is this one. Lambda by 2 is equal to 9. So which is lambda is equal to 18 centimeter. Okay. So this is also not true. So the correct answer is the option B. So the wavelength of this progressive wave is 18 centimeter. So let us go to the next question. This is also a very interesting question. There could be, so this could be asked in competitive exams. So what is the question? Equations of two waves acting in the perpendicular directions. There are two waves. That means, so one wave is progressing like this, another one is progressing like this. If these two waves is acting or overlapping on each other, then what kind of trajectory, sorry, what kind of resultant wave we will get? Whether we will get parabola, whether a circle, an ellipse, a straight line. So how to find out this kind of, like, find out the answer for this kind of problems? So the only way is that you have to look closely these two component waves and what are the phase difference between them. Look here, delta is there, and what is delta? Alpha plus pi by 2. So there is a relationship between these two. Let us check. So x is equal to a cos of omega t plus delta means alpha plus 90 degree. That means it is actually going to the, so pi by 2 is there, so it will anyway become sine plus alpha. Since it is actually cos, so starting from cos, so there will be minus sign, because all sine tan cos, you know that. So this is the resultant wave of, sorry, this is the wave which is actually the material particles of which is oscillating in the x direction. Okay, so we have got x by a is equal to sine of minus omega t plus alpha. This is 1, and 2 is this one. Suppose y is equal to given already, so we'll write here, there will be a. Okay, I have done some mistake while typing. So y by a is equal to cos of omega t plus alpha, equation 2. Now what we can do, we have to just square the left hand sides and right hand sides of both equation. Like, say, if we take square of it, and similarly I take square of the other one also, and then add them, then what we get here, anyway it will be sine square omega t plus alpha plus cos square omega t plus alpha. Okay, so this will give you 1, and here this side you will get x square plus y square is equal to a square. So this is our familiar equation and very simple equation of circle. This is actually equation of circle, of a circle, equation of a circle. Okay, so it is neither a parabola nor ellipse, even it is not a straight line also. It is a circle. So I hope you have understood how to solve this kind of problem. I'll repeat. First of all, you have to see what exactly x and y is, like x and y are. Then try to square them out, okay, only this cos and sine argument parts along with the argument. You have to see first of all what is there in the argument, whether both are same or not. Then only you can do this summation, this kind of summation and all. If they are not same, then you have to make somehow same this argument part. Then only you can square them out and then add or subtract whatever you can do. Okay. So you have to first look the argument. Here see, here in this case delta was given and delta is actually alpha plus pi by 2. So then we can get some idea that here also there will be alpha and all, and that would actually help you to square them out and then get the equation of the circle. All right, so let us go to the third question. So in this question, actually this question is related to standing wave. This question is related to standing wave. Okay. So standing waves are produced in 10-meter long stretched string. That means you have, sorry, you have stretched string. This string is of actually 10-meter long. This is 10-meter long. It vibrates in 5 segments. It vibrates in 5 segments, it says. 5 segments. So you can break them. Standing wave means like this. So 1, 2, 3. Okay, I have made it little bigger. We have to make little smaller so that we get 5 segments. Okay, so let us go with that now. This is one segment. This is another segment. See, so this is third. This is fourth, and again this is fifth segment. Okay, so like that, in fifth segment it is vibrating. So you have to find out the frequency over here. What is given? The velocity of the wave in the medium is given. Okay, so better to solve this problem, just remember the general formula for the frequency. General formula for the frequency that produces frequency of the wave, standing wave produced in a straight string. So what is the fundamental formula? You have to remember that. So that fundamental formula is nu is equal to n by 2 into L root over T by M. So in a string where T is the tension, M is the mass per unit length, so this will give you actually further, this N is the number of segments in which it is vibrating, and L is the length of the string, and this quantity is nothing but the speed of wave in the straight string. Now you can put the values. So as I said, this N is the number of segments. So how many segments? It is vibrating in 5 segments. What is the length? Length is 10-meter long. And what is the velocity? Velocity is given 20 meter per second. Okay. Now if you do the simplification, you will get this. This is the frequency. So 5 hertz will be the correct answer. I hope you have understood. You have to go with the fundamental formula for getting the frequency of the wave. Actually, this is actually, see, if I write 2, then it has 2 segment. 1 means 1 segment. Okay. So this actually, this n is the number of segments. Number of segments. Number of segments. Okay. And this t, square root of t by m, this gives the velocity of the sound wave. Okay. All right. So we have got the answer for this also. We'll go to the fourth question. So here also, this question also related to the stretch string itself, but it is the application of a stretch string. Application of stretch string. See, the if the tension and diameter of a sonometer wire of fundamental frequency n are doubled, so tension is doubled and double, diameter is doubled, and the density is halved, then the fundamental frequency will become what? So actually you have to find out the frequency formula. So we have got n divided by 2l root over t by m. Okay, so this formula can be replaced in terms of diameter and density. How to do that? So this formula actually, if you go for like we have already discussed it in our class. So this formula will be actually 1 by L into D, that is the diameter, and this will give you tau by pi into rho. You might be thinking how I am getting that. It is very simple. If we know the length of the wire and if we know the mass, okay, then mass per unit length will be m by L. Okay, but if the density is given, then we can write in another way. So mass into, so diameter, so diameter, that means, okay, so you have to find out volume into rho to get them. So pi, diameter is d, so pi d square, that is the diameter, area of cross section, into L, total L. This will give you the volume. Then you write, okay, so sorry, so this is actually volume. So volume into rho will give you the mass. Volume into rho will give you the mass. Like that, you have to actually find out the mass per unit length. Okay, mass per unit length. So this is the formula then to find out the frequency of fundamental frequency. So what is given? The tension has been doubled. Let us see what is there. And diameter also doubled. This is 2 into this. Okay. Tension is doubled, 2t now. And density is halved. That means this by root 2. Sorry, this by 2, rho by 2. So you get 2ld square root. So this is 4t pi rho. Okay. So what we can do is we can just take this 4 common. 4 common means you will get 2 over here. 2. Okay, then you get 2 ALD as usual, along with that natural frequency. That means it is so density is halved. Density is halved. N is double. Sorry, tension is doubled. Diameter is also doubled. Okay, so if we go with diameter is also doubled, so here another 2 will be there. Okay, so here 2 I have missed, so here another 2 will be there. Okay, another 2 will be there. Okay, so finally you will see here also 2 will be there. So this 2 will get cancelled, and anyway this is T by pi rho. So what I'm getting, new fundamental frequency as 2 by 2 into 2LD root over 4T by pi rho. So this is what we have got. So if you take 4 out of it, so this is the fundamental. Okay, I'll just not write this part first. So this is the fundamental frequency of a of a wave in straight string. So look here, from here actually 1 2 will come. So this is actually written already over here. So that's why this two get cancelled. Ultimately you get 2 ALD root over tau by pi rho. So this term is actually equal to the given frequency nu itself, or the original frequency. So original frequency here, original fundamental frequency is n. So now also it will be n only. So C will be the correct answer for this question. I hope it is understandable. Now we'll go to the fifth question. So this question is actually related to closed organ pipe. That means closed means one end is closed. Okay, is excited to support third over tone. Then it is found that air in the pipe has 3 nodes, 3 antinodes, 3 nodes, 4 antinodes, 4 nodes, 3 antinodes, 4 nodes, 4 antinodes. You have to find out how many nodes and how many antinodes will be there. So for that, you need to first know what is over node and how is it related to harmonic. We know that in case of closed pipe or one end closed pipe, only the odd harmonics will be excited. Only odd harmonics can be excited, not the all. All the harmonics will be excited in case of both way or both end open. Okay, so what is the expression for that? in this case, when you have one end closed, then the expression for the fundamental frequency is given by when one end is closed, right? So let me just give you the equation for the for one end open pipe or one end closed pipe, that is called actually closed pipe. So the fundamental frequency will get, actually the frequency, see, this will be V by sorry, this is actually this is n by 4L, n by 4L root over gamma p by rho. Okay, this is the fundamental, this is the actual natural. It will be actually 2n plus 1, 2n plus 1 by this, and n starts from 0. Okay, 2n plus 1 divided by 4L. Okay, and n starts from 1, sorry, n starts from 0, 1, 2, etc. So we'll get only odd frequencies or only odd harmonics here. See, new 1 here, new 1 means n is equal to 0. Then we get 1 by 4L root over gamma p by rho. Okay, and then you have, see, when n is equal to 0, it is actually the fundamental frequency, fundamental frequency or fundamental mode of vibration. It is called actually the first harmonic. First harmonic. Okay, first harmonic or fundamental note or fundamental note. This term you have to remember how it is called, fundamental note. Then when n is equal to 1, then it will give you actually lambda 3. This is called fast overnote. Sorry, overtone, fast overtone, fundamental tone, overtone. See, the fast overtone is actually when it is third harmonics. Third harmonics. All right. Third harmonics is fast overtone. This time you have to remember. Then when n is equal to 2, you get actually fifth harmonics. So fifth harmonics. And this fifth harmonics obviously will be the second over note. Sorry, overtone. Second overtone. Then now if n is equal to 3, then you get seventh harmonics. N is equal to 3 means you get seventh harmonic. So you'll get seventh harmonics. Seventh harmonics or or fourth, sorry, seventh harmonic or third overtone. So third harmonics, in this case, odd harmonics are present, like 1 is to 3 is to 5th is to 7 is to 9 is to 11. This is how harmonics are present. So this is called fundamental note, overtone. This is called first overtone. This is called second overtone, and seventh is called third overtone. Seventh harmonics is called third overtone. Harmonics is called third overtone. Okay, so third overtone or the seventh harmonics. Look how seventh harmonic looks. So how many notes are there and how many identity notes are there? You can find out. 1, 2, 3, 4. 4 antinodes. 4 antinodes. How many nodes are there? 1, 2, 3, 4. These are nodes. So 4 antinodes are there. 1, 2, 3, 4. Okay, 4 nodes. So 4 nodes and 4 antinodes will be there in this. So this is the correct answer. So what was the fundamental point over here to note? What is third overnote? Sorry, overtone. I'm sorry. I'm always telling overnote, but it is not overnote. This is called overtone. Third overtone. This is for open pipe. Actually, for close, see, open pipe, it will be third means third. Third means the fourth actually. Okay, third means the fourth. See, first fundamental one will be the zeroth or primary overtone. Then first one will be the first. Second will be the third harmonics, and fourth harmonics will be in that case also the, for open case it is the fourth harmonics. Fourth harmonics, and fourth harmonics means you have four uh, fourth harmonics means you have n means 4, so n 4, so fourth harmonics there will be different thing compared to this actually. Okay, but anyway, so this is how you have to see. In case of open and closed pipe, these are different actually. Okay, in case of open pipe, in case of open organ pipe, you have all the harmonics present. Okay, all the harmonics present. But in case of closed pipe, you have only this odd harmonics. Okay, that's why it is the first overtone, this is the second overtone, and this seventh one is the third overtone. Whereas in case of open pipe, this is the fundamental, this is the first, this is the second, and this is the third. Fourth harmonics will be the third overtone. Okay, so those things you have to remember. All right, let us go to the sixth one. Actually, this is sixth one. The sixth problem. If you study vibration of a pipe open at both ends, that means this open organ pipe. Okay, then the following statement is not, oh sorry, not true. So which of the following statements is not true? That is what you have to find out. So open end will be antinodes. That is true because we know that fundamental one will be like this. So both end on antinodes. This is true. Odd harmonics of the fundamental frequency will be generated. No, all the harmonics 1 is to 2 is to 3 is to 4 is to 5, all the harmonics will be present. So this is true, this is not true. Pressure changes at the both ends will be maximum. Yes, that is also true. Antinodes means pressure change will be maximum. So the B, option B will be the correct answer. Correct in the sense that is wrong statement for open organ pipe. So I'll stop it here for today. Next day we'll take few more important numerical problems. Okay, so next day means tomorrow. Tomorrow in the evening we'll be having class again. So tomorrow we'll take up a few more numerical problems because this is a very long chapter. Bits and all we have already read. So those things we'll take up tomorrow, and also this organ pipe and standing waves in various cases we'll take few more questions because this is very important, and as much as you can solve, that will make your idea very clear. Okay, so thank you for your patience. Bye for today.